This is lesson 74, VHDL example 47. And in this example, we'll write a VHDL program to debounce push buttons. This is very important because the push buttons on your FPGA board bounce when you push them. So you think that the outputs are going to go from 0 to 1 when you push the button, but really it may go from 1 and then it may bounce a little, that is, go back to 0 and come back to 1. And this can cause all kinds of problems in your circuits. So anytime you use the push buttons on the FPGA board, it's essential that you debounce them. Here's a circuit that'll do it. We use 3 flip-flops in series like a little shift register, and this input is going to be the push button. So when you push the button, this input will go from 0 to 1. Now we use a clock here. I call it C clock. This has to be a relatively low frequency clock. We'll typically use about 190 Hertz clock for this. On the rising edge of this clock, the input gets shifted in, and then on the next clock it gets shifted once more, and then shifted again. And you notice the outputs of these 3 flip-flops, I call them delay 1, delay 2, and delay 3, are the inputs to an AND gate, and this is going to be the output. So we'll see how this works. We're going to write a program called Debounce 4 that will debounce all 4 switches on your FPGA board. So the input's going to be an input 3 down to 0. You'll connect this typically to button 3, button 2, button 1, button 0. C clock is this relatively low frequency clock we'll bring in. Clear is our usual clear, and then the output will have 4 outputs. So we're going to make 4 versions of this circuit. Output will be out, standard logic vector 3 down to 0. So let's write the architecture for this. We'll write these signals for delay 1, delay 2, and delay 3. There's delay 1, delay 2, and delay 3, the outputs of the 3 flip-flops. Then our process will be C clock and clear. So if clear equals 1, we'll set delay 1 to 0, 0, 0, 0. Remember, delay 1 and delay 2, delay 3 are all 3 down to 0. That is, we have 4 versions of this, 1 for each push button. So delay 1 will be 0, 0, 0, 0, delay 2, and delay 3. Else, C clock tick event and C clock equals 1. That's the rising edge of C clock. Delay 1 gets the input. Delay 2 gets delay 1, and delay 3 gets delay 2. And then the output is just the AND of these, so the output is going to be delay 1 and delay 2 and delay 3. Now if we look at the simulation, we can see how it works to debounce the switches. I'm only going to use, say, button 0, which would be connected to input 0. And I made a little formula here which bounces. So here's C clock. This is going to be a relatively low frequency. This is a 190 Hertz clock. So here I show you pushing the button, but then the button sort of bounces. So it goes back to 0, and then it hits again and bounces, and now you have your finger completely down, and so it stays down now. So you get this little bounce here. You can also get some bounce when you release your finger. So you lift your finger up, maybe it bounces once here like I've shown. But let's see what happens. Here's the output 0. Notice the output 0 ends up being a nice clean signal. None of this jitter. All the jitter's gone away. And you see why. Well, it gets shifted in. So when you push this button, it gets shifted on the next rising edge of the clock into delay 1. Now, it went down to 0. So a 0 is going to get shifted in on the next rising edge of the clock, but this 1 moves over to here and then moves over to here. But this 0 now gets shifted to here, to here, to here. Then you get this 1, well, actually went back to 0, so it never got recorded at all. But then eventually, once you've held your finger down, for 3 clock pulses, this 1, this 1, and this 1. So not until you have 3 1s, because remember we AND them together. So delay 3 and delay 2 and delay 1, we finally get a 1 out. So any of these jitters which take place in less than 3 of these clock cycles, this is why we need to use a relatively slow clock, the 190 Hertz clock, because these bounces can typically be perhaps a few milliseconds, you see. So when we get a 1, 1, 1, the output finally goes to 1 and will stay there. Now your finger's all down. Now you let your finger up. Well, as soon as you let your finger up, you'll pump a 0 in. Well, as soon as you get a 0 in, the AND gate's going to go to 0, so it goes to 0. But even if it bounces, it could bounce up and down a few times here, and this 1 gets shifted over. You'll never get another 1 unless this 1 lasts for 3 clock cycles. But bounces don't last for that, so you'll get a nice clean falling edge as well. So we're really interested in debouncing this first end, you see, because usually things happen when you push the button, and you want to make sure that you only get a nice clean single edge when you push the button. And this debounce circuit will do it, so you should put this Debounce 4 VHD program in your little toolbox of useful programs, because you'll need to use it in any program where you're using the push buttons.